All right, the problem of the day was a synthesis problem that you got to take home and work on. Hopefully you had a chance to talk with a classmate or a partner about the synthesis, because sometimes if you get stuck, they can help you get through the bottleneck. In the directions, I said that you can use organic building blocks containing 4 carbons or fewer. I know I got a couple of emails asking if that 4-carbon building block can have a halogen on it. That's fine. You could show how to do it without a halogen as well. But let's start from the beginning and go backwards. So we have a ketone as our product. Oops. Oh, I'm forgetting a carbon. There we go. And we have a couple different ways to make ketones. What ways do we know how to make ketones? So I heard acid catalyzed hydration with an alkyne. Is there another one?
Ozonolysis with an alkene.
Ozonolysis of alkenes. How many of you guys chose the alkyne route? So it looks like the majority chose the alkyne route. So we'll go with that route. So if you've got an alkyne, you can do it that way. I'm going to write another one down here too. And then we've got to choose. How many of you chose the one on the top alkyne? So the top alkyne, if we look at it, is symmetric. Regardless of which side we form the enol on, it will tautomerize to form the exact same molecule. If we chose the bottom alkyne, we'd actually get a mixture of 2 different ketone products. So the top one would be the most efficient here. So let's erase this one. So we've got this top alkyne, and the question is, how can we make this? We know we need to start breaking it apart into fewer or smaller carbon chunks, so I would go with an alkylation step here. And we know we can do this a few different ways. We can have this alkyne, and we can eventually deprotonate it, and we can react it with an alkyl halide, right? So I haven't shown it as the acetylide ion, but you can imagine deprotonating the terminal proton on that alkyne and do a SN2 alkylation. And then from here, we need to go even further. Because this isn't 4 carbons, it's 6. We need to break it apart even further. And from here, we can show this reacting with regular acetylene. So let's use the bottom half of the page to show our overall synthetic route. So the first step, I would say, would take your acetylene, react it with a strong base, something like sodium amide. That will give you your acetylide ion. And then with this, we can react it with our alkyl halide to give us our precursor. And then to this, we can react it with another equivalent of sodium amide to deprotonate that precursor we just made. We can react this with our same alkyl halide as before. And now we've got our symmetric alkyne. And then our last step was our acid catalyzed hydration. So that was H plus, H2O, and mercury sulfate. And then we finally get all the way to our desired product. And if you wanted an extra challenge, you could even show how you make that alkyl halide. I'll quickly show it on the bottom. If you want to show making that alkyl halide, you would first have to start with 2-methylpropane. React this with Br2 and UV to brominate it. Then you can react this with sodium hydride to get your alkene. And then you can do HBr and your acid. Or sorry, your peroxide. So if you really wanted to show going straight back all the way to your alkane, you can actually do that for this reaction. I'll try to be as specific as possible when I give you guys directions. Otherwise, if I don't specifically say it, you've got free reign to use whatever reagents you want. Sound good? So this was a little challenging. Again, working backwards makes it easier. You can ask yourself, what reactions do I know how to make this functional group with, and then work backwards step by step.
Can you show how we do the ozonolysis?
The ozonolysis one is much, much harder. If you want, we can talk about that later. We haven't really discussed alkylation for alkenes yet. We will cover reactions like that later on in the term, though. Yeah. All right, so did everybody get the in-class activity for the synthesis problems? They should be up on the front. Uh-oh. Here it is. All right, so for the in-class synthesis activity, what we're going to do is have you spin tables around again, like we did in our last activity, and work in groups of 4 to 8. And what I'm going to ask you guys to do is to try to plan a synthetic route working from your product, working backwards all the way to your starting material. You can use any reagents we've covered in this class, any carbon-based reagents even, but you do need to use the reagent shown on the left. So in the first one, you need to use 3-methyl-butanol in order to form the product at some point in the reaction. And what I would recommend doing is talk with your neighbors, see if you guys can bounce ideas off of each other and come up with a decent route. And then we'll meet up and have people write their best answer down on the board, and we'll see if everybody agrees or not. All right.
Wait.